Hello students, welcome back. Now let's go over to problem 3, another confidence interval problem, but this time it's going to be about proportion. The most recent poll conducted by CNN-ORC, May 3rd of 2016, finds Hillary Clinton leading Donald Trump by 54% to 41%. This poll result is based on a total of 890 registered voters. On the other hand, the most recent poll by Fox News, April 14th of 2016, has Clinton leading Trump by 47% to 40%, based on 1,021 likely voters. And then we have to do some confidence interval problem. By the way, this is the original problem here, and the date I wrote this exam problem was May 11th of 2016, and the most recent here and there refer to the most recent from the early week of May of 2016. Nowadays, of course, those are old newses. This is the original problem. And then, by the way, here are the sources if you're interested. Okay, let's go to the problem. Based on CNN-ORC poll, find a 97% confidence interval for projected proportion of Clinton supporters. Okay, let's go ahead and do that. So the first problem is about CNN-ORC poll only. So the second one, Fox News, you don't have to read it. Throw all these away. And then let's consider the previous sample statistics only. We have what? 54%, 41%. So in terms of decimal, 0.54 versus 0.41. Okay. Another important statistic is sample size of 890. And the other part are not important. Okay. Let's make decision. In order to find out the confidence interval, we have to make decision about a curve, t-curve or z-curve. Which is it? In this case, it should be a z-curve, of course, because look at the number. 890 is certainly bigger than our typical threshold of 100. So we're going to use z-curve. Now that we have z-curve, let's draw an initial picture. And looks like this, going up and down, unimodal, symmetric, and so on. And the center is, of course, observed mean. Now, 54% versus 41%, which is the observed mean? The problem asks about Clinton supporters, so Clinton number, 54%, based upon that poll. I'm not talking about the reality. We already know what happens in real election. That's not the problem we are talking about. It's this particular poll we are doing here. So 54% goes to the center, and then we are looking for this left-hand side and the right-hand side endpoints. We have 97% confidence interval, so confidence level, 97% of chance should be in the middle, highlighted in green. So the other 3% must be shared by left-hand side, 1.5%, and the right-hand side, 1.5%. Okay, all right. Now that we got the picture, the most important step, let's go to the solution. We used the formula z equals to n minus center over sc, but in order to use that sc, we have to find out the standard error. And what's the standard error? Square root of p1 minus p over n, and that's something everybody should remember. I'm not going to deduce this formula for you. I don't think we can do that in 1000 level either. In 3000 level, maybe we can. And by the way, what is this P observed proportion? We're doing Clinton, so we're using this one only. 41%, we don't use it, okay? So if this is Clinton versus not Clinton, then maybe, but this is about Trump. And then there may be undecided or some other supporters, Sanders or whatever. So we don't use the other. Just 0.54, 1 minus 0.54, and their sample size is 890. So calculate this number using your calculator. You're going to get 0.0167 something. That's going to be your standard error. That's going to go down to the denominator. So end minus center over SC. Oh, by the way, this is normal z-curve. So I generally prefer to do it from the left. End minus center over SE. I could do it from the right, just like the t-curve, but I like to do it from the left. So n minus center over SC. Now, what is the z-score associated to 97% in the middle? In other words, 1.5% here. 1.5%, 0.015. Well, let's look up the table. This is a z-table, and let's look up 1.5%. 0.015. Where is it? Right here. Negative 2.17, isn't it? Negative 2.1 row, and then 07 column. Negative 2.17. That's where this negative 2.17 is coming into play. So n minus center over SE, where SE is, well, as we calculated this one. So let's solve that equation. N minus center over this SE, which is this. So flip over the denominator to the other side, then you're going to get this times that, flip it over, and then flip over this subtraction to the other side, then I'm going to get plus. And then 2.17, I don't need this part. 0.54 minus 2.17 times standard error. Just calculate this number. You're going to get 0.503 something. And it's going to be about 50.37% or something. 0.5037. That's going to go over here. Again, I'm using color coding so that you can see things better. How about the symmetry? And how about the other one? Excuse me. You will use the symmetry. From the center, we subtract it to get to the left. So from the center, we add something to get to the right. So change this minus to plus, then you're going to get the right value. 0.54 plus 2.17 times standard error. You calculate this quantity, punch it to calculator, you get 0.576 something, 57.6 something percent. So that's going to be your confidence interval, and here's your conclusion. 54% in the middle, 97% in the middle, and it begins from 50.37% and then 57.625%, approximately speaking. Okay, do we have time to go over to the next problem here? No, let's do it in a separate video. See you soon.